Measures of Position and Outliers, Part 2. Lesson Objectives. In the previous video, we learned 3 lesson objectives. In this video, we're going to determine and interpret the interquartile range and check for a set of data for outliers. Lesson Objective number 4. The interquartile range, denoted IQR, is the range of the middle 50% of the observations in a data set. That is, the IQR is the difference between the first and third quartile, and it is found by using the formula Q3 minus Q1. We will use the example of the BYU students. Here's the data for the 14 randomly selected speed of vehicles. We're going to determine and interpret the interquartile range for that data. So Q1 is 28 miles per hour, Q3 was 38, so the IQR, the interquartile range, is 10 miles an hour. Now what this means is the range of the middle 50% of the speed of the cars traveling through this construction zone is 10 miles per hour. Let's look at the student survey data. If you recall, we found Q1 to be 20 and Q3 to be 29. Q1, Q3. If we calculate and interpret the interquartile range for the age variable, Q3 is 29, Q1 is 20, so the interquartile range is 9. The range of the middle 50% of student ages for the early fall term 2009 is 9 years. Now suppose a 15th car traveling through the construction zone was clocked at 100 miles per hour. How does this value impact the mean, the median, standard deviation, and our interquartile range? The mean without the 15th car was 32.1 miles per hour. Including the 15th car, it increases to 36.7 miles per hour. The median without the 15th car was 32.5. With the 15th car, it goes to 33 miles per hour. So this 100 miles per hour had a bigger effect on the mean than it did the median. And if you recall, the median is more resistant to outliers than the mean. Standard deviation without the 15th car was 6.2 miles per hour. With the 15th car, it goes up to 18.5 miles per hour. The IQR is 10 miles per hour without the 15th car and goes to 11 miles per hour with the 15th car. So this is to illustrate that the IQR is resistant to these large values where the mean and the standard deviation are not. So if your data set is skewed or has outliers, to measure the spread you should use the IQR. Let's summarize this. If the data is symmetric, to measure the center, the typical value, you should use the mean. To measure the spread or the dispersion, you should use the standard deviation. Now if the data set is skewed, left or right, the median should be used for the measure of central tendency. And to measure the spread, the interquartile range should be used. Lesson objective number 5. Checking for outliers using quartiles. First step, you compute the first and the third quartiles. Then you compute the interquartile range. And step number 3, you determine the fences. The fences serve as cutoff points for determining outliers. Now outliers are values that are extremely small or extremely large relative to the rest of the data. So the lower fence would be Q1 minus 1.5 times IQR, and the upper fence would be Q3 plus 1.5 times IQR. Any data value is less than the lower fence is going to be considered an outlier, and any value larger than the upper fence is going to be considered an outlier. So let's do an example. This is for the speed data. Q1 is 28, Q3 was 38. The IQR turns out to be 10. So the lower fence would be Q1 minus 1.5 times IQR. So that's 28 minus 1.5 times 10. So that's 28 minus 15, which is 13 miles an hour. The upper fence is Q3 plus 1.5 times IQR. So that's 38 plus 15, and we have 53 miles per hour. That's the upper fence. Since there's no values that were smaller than 13 or larger than 53, we say the data set has no outliers. Now the way we're going to determine if there's outliers in this class is to use Minitab or StatCrunch. And we're going to look at the box plot and it will tell us if there's any outliers. So in Minitab, we go to Graph, Box Plot, and then we select Simple. Hit OK. Select our variable, hit OK, and we have our box plot. Any outlier is identified by these little stars. Now most people like to view box plots horizontally instead of vertically, and Minitab can do that. We go back to box plot and we hit scale. In this window we check transpose value and category scales, hit OK, and now Minitab displays a horizontal box plot. And for most people this is easier to read, so we can estimate these values by using the graph. So all these values here, these stars, would be considered outliers. Okay, let's look in StatCrunch. We go to Graphics, choose Box Plot, select our variable, and then we hit Next, and we have to be sure to click this box, use fences to identify outliers. We want to make sure that's clicked, and if you'd like to see your box plot horizontally, click it here too. Hit Create Graph, and this is the box plot graphed in StatCrunch. Thanks for watching.